Welcome to ASA. In this video, we're going to look on equilibrium of a particle. So we have a problem that we want to solve. We have this system which have 3 pods, and we're given some additional information. We're told that if block B weighs 200 newtons and block C weighs 100 newtons, determine the required weight of block D and find the angle theta for equilibrium. So first of all, let's write the given data. So I told that block B weighs 200 newtons, so that is going to be the downward force of board B. And I told that board C weighs 100 newtons, so that is going to be the downward force of board C. We're told that the system is in equilibrium, that means there's no movement. So there's going to be tension in the cables. Let's look at B. So there's going to be tension in the cable B or in the rope B, which we are going to call TB. There's also going to be tension on the rope which holds board C, which we are going to call TC. Since the rope which holds board B is extending to the center, so that means we're going to have the same tension, so it's going to be TB. And the same is going to happen to the rope which holds the board C. And we're also going to have tension in the rope which holds the board D, which is going to be TD. Since I told that the system is in equilibrium, that means all you have to do is to write our static equilibrium equation. So that means the sum of all the forces acting along the x-axis and the sum of all the forces acting along the y-axis should be equal to 0. So we're going to use those two equations to find the weight of the board D and the angle theta. So now let's draw our imaginary y-axis. Now we're going to go to board B. We're going to resolve upwards. As you can see, we don't have any force acting along the x-axis on board B, so that means we're only going to resolve upwards. TB is the only force that we have, so that means TB is equal to 200 newtons. That is going to be our first equation. Now let's go to board C. So on board C, we don't have forces acting along the x-axis, only have TC, which is acting along the y-axis, and also you have 100 newtons, which is acting downwards. So that means TC and 100 newtons should be equal to maintain equilibrium. Now let's go to the center right here. As you can see, we have two ropes with different tensions, and you know that the side which includes the angle is going to be cos theta, and the side that doesn't include the angle is going to be sin theta. So let's start by resolving along the y-axis. So we're going to have TB sin theta plus TC sin 30, and this should be equal to the weight of the body D if we resolve along the y-axis. Now we need to resolve along the x-axis. On the x-axis, we only have two forces. We have TB and also have TC. So that means TB cos theta and TC cos theta should be equal. So we're going to write our fourth equation, TB cos theta equal to TC cos theta. So these are the equations that we are going to use to find the weight of block D and the angle theta. Okay, so all we have to do right now, as you can see, we're given TB, we also have TC. Equation 1 says TB is equal to 200, TC is equal to 100 newtons. So that means we need to substitute equation 1 and equation 2 into equation 3 and equation 4. We no longer have to write TB and TC, but we're going to write 200 or 100. So let's do that. So let's start with substituting equation 1 and equation 2 into equation 3. So instead of writing TB, we're going to write 200. Instead of writing TC, we're going to write 100. And for sin 30, remember sin 30 is a 1/2 or 0.5. So we're going to have 200 sin 30 plus 0.5 times 100 is equal to D. That is going to be our fifth equation. Now let's go to equation number 4. So we're going to substitute equation 1 and equation 2 into equation number 4. Instead of writing TB, we're going to write 200. Instead of writing TC, we're going to write 100. So that means we're going to write 100 cos theta is equal to 100 times 0.866. Remember, cos theta is equal to root 3 over 2 or 0.866. Then from here, you can see that if we divide both sides by 200, we can find the value of cos theta. Okay, so let's do that. We're going to get our cos theta 0.433, but we need theta. That means we have to take the cosine inverse If we do that, we're going to get our answer as 64.3 degrees. Now let's go to equation number 5. Here we now have the value of theta. So all you have to do is substitute the value of theta into equation number 5. Instead of writing sine theta, we're going to write sine 64.3 degrees. And if we do that, we're going to get our D as 230.22 newtons. So thank you for watching. If you enjoyed, I hope for your support in form of likes, comments, and subscribing. The other thing, we now have some membership in our channel. If you want to access members only video, members only shorts, and members only live stream, click in the link in the description. Thank you for watching.